Nitric oxide is a gas. And 99% of the products on the market are basically giving you precursors or substrates or amino acids and hoping that your body can convert it into nitric oxide. But the problem in people that are nitric oxide deficient is that they've lost the ability to convert those substrates or precursors into nitric oxide.
Stress is the inflammation that robs us of life, energy, and happiness. Our typical solutions for gut health and hormone balance have let a lot of us down. We're over-medicated and underserved. At The Less Stressed Life, we're a community of health-savvy women exploring solutions outside of our traditional Western medicine toolbox and training to raise the bar and change our stories. Each week, our hope is that you leave our sessions inspired to learn, grow, and share these stories to raise the bar in your life and home. All right, today on The Less Stressed Life, I have Dr. Nathan Bryan, who's an international leader in molecular medicine and nitric oxide biochemistry. Dr. Bryan earned his undergraduate bachelor's degree in biochem from the University of Texas at Austin and his doctoral degree from Louisiana State University School of Medicine in Shreveport, where he was the recipient for the Dean's Award for Excellence in Research. He actually has like a 10-page bio, but I'm going to summarize it to this. He's basically been involved in nitric oxide for the past 20 years and has had many seminal discoveries in the field. He is involved in development of products and drugs using nitric oxide, and his lead drug candidate called NOviricid is currently in phase 3 clinical trials for the treatment of COVID-19 in African Americans and Hispanics. So we'll talk all about nitric oxide today. Welcome, Dr. Bryan.
Krista, thanks. Great to be here with you. Thanks for having me.
Yeah, I love these nerdy topics. So does the audience. They love like specific, really nerdy topics. So nitric oxide, I feel, has gotten a little bit of more of main stage presence as mouth taping became popular. But let's just back up to nitric oxide 101. And also before we even go there, how did this become your life's work, or why? And it may be not that cool of a story, right? It may have just been like, this is what they had research dollars for. But how did this become, or is this an area you felt really passionate about? How did you end up in nitric oxide research and then stay there for as long as you have?
Yeah, well, Chris, it's like any career, right? It's a journey. And I think we encounter different things in different parts of our life that allow us to pivot. But, for me, there was an early interest in science and medicine, even from high school. And so once I got a degree in biochemistry and really tested the job market out for a bachelor's degree in biochemistry, and there really wasn't all that many opportunities. So I realized I quickly had to go back and further my education. And so I knew I always wanted to do basic science research. I loved the feeling of discovery. I did undergraduate research at the University of Texas. But I enrolled at LSU in a PhD program in cellular molecular physiology back, I guess it was 2000. And during that time, we have to take all the courses, and then we rotate through some research labs. And one of the labs I rotated through was with a pharmacologist that had been in nitric oxide for probably about 15 years before that. And so we knew it was important. A Nobel Prize was just awarded for the discovery of nitric oxide in 1998. And it was really intriguing to me, but it was this gas that was produced in the lining of the blood vessels, and it was gone in less than a second. Mm-hmm. So there was still a lot of unanswered questions around nitric oxide, like, what goes wrong in people that can't make it? What are the clinical consequences? And then how do you detect and measure this molecule in humans or in patients and develop some type of prognostic or diagnostic molecular pattern on, at-risk patients? Mm-hmm. So that really piqued my interest. And then, we started developing methods where we could detect nitric oxide at really low physiological concentrations. And then that really gave us the tools we needed to really discover a lot of things that hadn't been discovered before. So, during that time as a student, I think I published 5 or 6 papers. And then, in my postdoc, we were publishing 8, 10, 12 papers a year. And then that's really how I got a name for myself, kind of a young up and coming guy in analytical chemistry and nitric oxide biochemistry. And, we made a lot of discoveries, and that's how I got into this field. And that's what continues what I do today. We've learned a lot, but, there's still a lot we don't know.
Right. Well, you brought up some of the questions that I have for sure, which is, but before we get into kind of how does our body make nitric oxide? I mean, as we look at supplements and things, how do you even stabilize this when it's gone in a second? But before we get there, why do we even care about nitric oxide? So tell us just a little bit of the 101 about why do people need to even know what it is?
Well, it's a gas. It's a molecule that's produced in the lining of the blood vessels. That was the first pathway to be discovered, or the first cell type to be discovered. But now we know it's produced in the brain and the neurons. It's how our immune system fights off invading pathogens from viruses and bacteria. So it's critically important in our immune dysfunction. And I'm certain we'll go there when we talk about our COVID drug and how we recognize that nitric oxide deficiency was what was causing people that got COVID, causing them to get sick and die from COVID. So now it's recognized that the loss of nitric oxide production is the earliest event in the onset and progression of most, if not all, chronic diseases. So we should care about it because, in America, there are a lot of poorly managed diseases or medical conditions. And the reason for that is they don't get to the root cause. And it's recognized now that the body cannot and will not heal without sufficient nitric oxide production. So there's two people we always talk to. There's the people who have been sick and can't get better, and they're sick and tired of being sick and tired. And then they're the people who find nitric oxide and realize, oh, now this may be the missing piece of the puzzle that's preventing me from getting better. Mm-hmm. So those people are looking for solutions to problems that they're living with and lived with for many years. Or there's people, Krista, like you and I, who are typically healthy and don't want to get sick. And we want to employ these strategies to allow our body to do as it's designed to do, and that's heal and regenerate. So for us, nitric oxide is critically important as kind of a preventative or a prophylaxis for development of chronic disease.
Mm-hmm. Can you talk to me about how the body makes it in the body? What are the other cofactors or the pieces that have to be at play for the body to make nitric oxide?
That's a very good question. So there's two ways the body makes nitric oxide, and they're completely independent production pathways. So in the early 1980s, it was discovered that there's an enzyme that they called nitric oxide synthase. That's the enzyme that's found in neurons. It's found in our endothelial cells, which are the cells that line all blood vessels throughout the body. And it's also found in our immune cells. So this enzyme converts L-arginine, which is a semi-essential amino acid, into nitric oxide. But that's a very complex, complicated reaction. In fact, you need 8 different cofactors and substrates to make that reaction work. And so if any of these are limiting or they become oxidized because the patient may be inflamed or under a lot of oxidative stress, then that enzyme becomes uncoupled and dysfunctional. So it no longer generates nitric oxide. Mm-hmm. So some of those cofactors are tetrahydrobiopterin or BH4. You need flavin-dependent cofactors. You need oxygen, you need glutathione, you need heme iron, calcium. So if any of those are limiting, this enzyme shuts down and you can't make it. Mm-hmm. So that's the primary, and we call that endothelial dysfunction. And that enzyme becomes less functional with age. So there's this age-related decline in nitric oxide production that is due to the insufficient production by that NOS enzyme.
Mm-hmm. I could see lots of issues with the cofactors there, not having enough of those. There's a lot of building blocks to make those. And then if you don't have those, you couldn't make nitric oxide. So I can understand where that would be an issue. And the second.
Yeah. And so, fortunately, we know how to recouple that and replenish those cofactors. But the second pathway is through our diet. And this explains the mechanism of, the Japanese diet, a vegetarian, plant-based diet, the dietary approaches to stop hypertension, because certain selections of food, primarily green leafy vegetables, have a higher concentration of a mineral called nitrate. And then the body converts, when we consume nitrate through our diet, by the activity of the bacteria that live in and on our body, they metabolize nitrate into nitrite and nitric oxide. So this pathway is dependent upon 3 things. Number 1, that we get enough nitrate from our diet. Number 2, that we have the right oral bacterium, the nitrate-reducing bacteria that are responsible for metabolizing this molecule. And then 3rd, we have to have sufficient stomach acid production in order for this pathway to work.
Oh, well, there's still more issues.
That's right. These
are a lot of building blocks to go down.
Yeah, there's a lot of things that get in the way of nitric oxide production. And, when we revealed probably 10 or 15 years ago that the use of mouthwash disrupts the oral microbiome and prevents nitric oxide production, causing an elevation in blood pressure and causing loss of the cardioprotective benefits of exercise. There's 200 million Americans that wake up every morning and use mouthwash. And I think they do it with good intentions, but people don't understand there's collateral damage to these things. And just like we don't take an antibiotic every day for the rest of our life because of the known medical problems that result from chronic antibiotic use from, why would we use a mouthwash to disrupt the oral microbiome every day? But yet people do.
Mm-hmm. So this one, we need nitrates from green leafy vegetables. The body's going to metabolize that into nitrite and then nitric oxide. We need the proper oral bacteria. We need stomach acid. You said one more thing, I think, for this one to work, right?
Well, there's three. We have to get enough nitrate in the diet, and the standard American diet is really depleted in nitrate, so we're not getting enough from the standard American diet. We have to have the presence of the bacterium, so that's two, and then the third is stomach acid, and that's really a problem because there's 200 million prescriptions written for antiseptics or not antiseptics for antacids, specifically proton pump inhibitors, and that shuts down nitric oxide production from both paths. So now there's clear evidence that people who have been on these PPIs, these antacids, for 3 to 5 years have about a 35 to 40% higher incidence of heart attack and stroke.
So let's talk about how we measure nitric oxide in the body, because you've now piqued our interest that, it's really important in immune dysfunction. And then we've talked about how it's created and all the issues for it. So how do people know that they have enough nitric oxide? Did you come up with ways that you can measure it in the body?
That's been a challenge for 20 or 30 years is how do you clinically measure nitric oxide deficiency? And because it's a gas, it's gone in less than a second. It's not something we can measure like cholesterol or vitamin D or triglycerides in our blood. So we rely on really symptoms. But, I developed a salivary test strip, I guess maybe 10 or 15 years ago, because people, just like the question you ask, is how do you know? And so the only way to measure that was we created the only point of care, non-invasive diagnostic in the form of a salivary test strip. So you can just apply some saliva to the end of this test strip. And if it turns bright pink, then that tells us that your body is able to generate nitric oxide or inorganic nitrite through this enterosalivary circuit. So, but it's, I tell people it's a good tool to have in your toolbox, but it shouldn't be the only tool you use. So we really rely on symptoms. So how do you know if you're nitric oxide deficient?
Yep.
If you have an elevation in blood pressure, your body's not making nitric oxide. If you have insulin-resistant diabetes, your body's not making nitric oxide. If you get winded and out of breath walking up a flight of steps, then your body's not making nitric oxide. If you can't remember where you left your keys and you're developing forgetfulness and mild cognitive disorders, then your body's not making nitric oxide. If you have erectile dysfunction as a man or a woman, then your body's not making nitric oxide to dilate the blood vessels of the sex organ to get engorgement. So all of those are kind of the primary signs and symptoms of nitric oxide deficiency. And the test strip is kind of a good way to validate that or verify it.
Well, those were more severe symptoms, but if you're a healthy person, fatigue would be one, right? Is there any other ones that are less severe that we could maybe look to for, hey, maybe I could increase? And I also want to talk about not only symptoms for maybe a more healthy person, but we talked about these other two pathways. And then I want to talk a little bit about mouth taping and how that increases nitric oxide, if you have feelings about it.
Yeah, no, there's many ways the body makes nitric oxide. So, if you develop chronic fatigue, which is a mitochondrial dysfunction, right? It means the mitochondria aren't making sufficient energy to power the cell. Nitric oxide is what controls and regulates mitochondrial ATP production. So again, if you develop chronic fatigue or you're just tired, lethargic all the time, then typically that's a sign of nitric oxide deficiency. Neuropathy, where you have, tingling or loss of sensation or sensory or motor function in the periphery and the arms or the legs, then that's a sign of nitric oxide deficiency because those small sensory nerves or motor neurons have to have a blood supply. And when they're not getting sufficient blood supply, then they lose their function and you develop neuropathy. So those are kind of the milder symptoms. But yeah, when you talk about, how do we increase nitric oxide production? Well, it's a very complex science, but it's really a very simple strategy. So it's diet and lifestyle, it's moderate physical exercise, it's deep breathing. So nasal breathing or mouth taping. And so the same enzyme that's found in the lining of the blood vessels is also found in our epithelial cells that line all the sinus airways, the airways of the sinuses. And when we breathe through the nose, there are mechanoreceptors on those cells that tell that cell to make nitric oxide. So when we breathe through our nose, we're signaling the body to make nitric oxide. And then we deliver that nitric oxide to the pulmonary vasculature. We dilate the bronchioles, we dilate the pulmonary arteries, and we improve oxygen uptake and we improve oxygen delivery to every cell in the body. But the mouth breathers, you're bypassing that pathway. So you're not stimulating nitric oxide production. But here's the problem, Krista. In people with endothelial dysfunction, they also have epithelial dysfunction, meaning if that enzyme nitric oxide synthase isn't working in the lining of the blood vessel, then it's not working in the sinuses, in the epithelium of the sinuses. So you can tape your mouth and do nasal breathing all day till the cows come home. But until you correct the function of that enzyme, you're not going to generate nitric oxide.
Yeah. Well, let's talk about, can you overdo nitric oxide? So, and this would be from an exogenous, probably the question before this is, can you take exogenous nitric oxide? I mean, there are supplements out there, but how do you make this stable?
Yeah, and that's been the confusion around consumers by these companies marketing nitric oxide products now for probably more than 30 years. Since 1998, there's been a number of companies that have hit the market with nitric oxide products. But the challenge has always been nitric oxide is a gas. And 99% of the products on the market are basically giving you precursors or substrates or amino acids and hoping that your body can convert it into nitric oxide. But the problem in people that are nitric oxide deficient is that they've lost the ability to convert those substrates or precursors into nitric oxide. So most of those products, the analogy I always use is it's like putting gas in a car with a blown up engine. These people aren't out of fuel. They're not out of substrates or precursors, or they're not deficient in arginine or citrulline. They've just lost the ability to convert those into nitric oxide. So those products don't do anything. Arginine, citrulline-based products don't do anything. Your body makes enough of those amino acids to saturate the enzyme. So what we've done is completely different. Our whole concept when we were developing this in the research lab was, number one, if your body can't make nitric oxide, then we have to do it for you. We have to generate nitric oxide gas. And that's really been my claim to fame, is I was the first person to develop a solid dose form of a bioactive gas. And so we have to do this in the form of a lozenge in this matrix that falls apart when you put it in your mouth. And then as this matrix falls apart, these active components come together and we generate nitric oxide gas. And that's really the only way you can deliver it, besides in a nasal cannula delivering the gas directly into patients, is through this lozenge.
It has to be in lozenge form.
It has to be in lozenge form. Yeah, because you can't put it in a capsule, you can't put it in a tablet, because, depending on if that person makes stomach acid or not, or if you don't have the right bacteria, then that product's not going to work for you. So what we do is we generate nitric oxide, whether you have the right oral bacteria or not, whether you have stomach acid production or not. So the beauty of that is this product technology works in every single person the exact same way, depending upon whatever their underlying condition is. And so the next question you asked was, how do you know if you're too much? Well, there are only two signs of toxicity for nitric oxide. One is low blood pressure. So if you take too much, your blood pressure will drop to an unsafe level, or you develop what's called methemoglobinemia, and you'll develop cyanosis. So too much nitric oxide will oxidize the iron and hemoglobin and, reduce the oxygen carrying capacity of your blood. And you'll get, cyanosis, blue around the lips. But we've never seen that. And that's, it's a serious medical condition. But, you would have to almost intentionally overdose on nitric oxide to get to that level.
Yeah. How much would you have to take for that to happen? Would you guess?
Well, the LD50, which is the lethal dose that would cause death in 50% of the people who take it, obviously these are done in research animals, mice, is tons. So probably, in terms of our lozenges, if you took 100 of our lozenges at one point, probably some bad things are going to happen to you.
Got it.
Yeah, if you take 100 Tylenol pills, you're going to die too. So the dose dictates the poison.
Right.
So,
yeah.
We've never had an issue with anybody overdoing the lozenge, because number one, we have to safety first, do no harm. Then number two, we have to generate a certain amount of nitric oxide that's biologically active that'll elicit a physiological response. And that's exactly what we've achieved with our technology.
So aside from overdose, which is would be very challenging to actually accomplish, and you'd have to do it exogenously, there really is no other harm to you're expanding blood vessels. So aside from low blood pressure, there's no other known harms from increasing nitric oxide, right?
That's right. Well, years ago, Krista, when probably in the early 2000s, a lot of clinicians and researchers thought that septic shock and the end organ failure from sepsis was due to an overproduction of nitric oxide production. Because when you get septic, your immune system generates a lot of nitric oxide to try to kill the infection. And the thought process was, well, that's leading to systemic vasodilation, loss of perfusion pressure, and then end organ failure and death. So they actually designed some clinical trials to give a nitric oxide inhibitor in septic patients. And the results were catastrophic.
Yeah.
The people that inhibited them, and the patients that got the NOS inhibitor actually did worse than those who got the placebo. So inhibiting nitric oxide production actually killed more people from sepsis than the placebo. So that told us that really the nitric oxide being produced during sepsis is actually protective and not causal for the hypoperfusion and end organ failure. So that really kind of changed the landscape, because now today there's no known clinical situation where overproduction of nitric oxide is causal for the pathology.
Well, I can't leave this one piece. You were talking about people are not converting into nitric oxide because they've got endothelium or epithelium issues. So are we saying that this is a mucosal issue, or is it enzymatic dysfunction?
So there are a lot of things that contribute to that enzymatic dysfunction. There's limitation of cofactors. So if you don't have enough glutathione, or tetrahydrobiopterin becomes oxidized, or calcium and a lot of these other cofactors that we discussed earlier, if they're not being delivered to these individual cells, then that enzyme can't do its job. So then we have to, recouple that enzyme. And so fortunately, we know how to do that, prevent the oxidation of tetrahydrobiopterin, which is the rate limiting step in nitric oxide production. And so all of that technology is found in our lozenge. We provide a certain redox potential that prevents BH4 oxidation. So the beauty of our technology is if your body can't make nitric oxide, we do it for you. But we also improve the body's ability to make nitric oxide on its own. And that's really unique to this particular technology, because no other nitric oxide product on the market does that. They're simply just giving you, substrates and cofactors that your body can't convert, with no regard to the activity of the enzyme that needs to be recoupled.
Are there specific enzyme SNPs that say, hey, if you've got this gene, you're not going to convert nitric oxide? Or there's actually lots of them, aren't there?
There's several. So obviously, if you have a SNP or a single nucleotide polymorphism in the eNOS or nNOS gene, then obviously that protein or enzyme is not going to be functioning. So that's the obvious one. The not so obvious one, and the one that's really prevalent, is an MTHFR, this methyl tetrahydrofolate reductase enzyme. So it's obviously involved in the methylation cycle and methylation pathway, but it's also the enzyme that reduces biotin to tetrahydrobiopterin. And that's the rate limiting step in nitric oxide production. So if you have an MTHFR SNP, then you become nitric oxide deficient. And depending upon which studies you read, sometimes that's as much as 45 to 55% of the US population has either a heterozygous or homozygous SNP in the MTHFR gene. So that becomes really a problem. Those are the obvious ones. There are others, all these biochemical reactions feed into one another. So there are things that are even further upstream than MTHFR that could contribute to nitric oxide deficiency.
Yeah. And I think about if the main issue is enzymatic dysfunction, I like to think about what are the things that are influencing the genes besides the genetics, but lifestyle, diet, all the things that you mentioned, it's a very complex set of reactions, but it's basically like good diet, good, like a bit of exercise. And the other things I heard from you were good stomach acid, not using mouthwash every day, nasal breathing instead of mouth breathing, which is a whole conversation on its own almost, with like potentially the way our mouths have evolved, possibly, or just stress and all those things. Leafy greens, or we didn't talk about beets, right? Beets are hailed for their nutrients that help make nitric oxide production. Correct me if I'm wrong, if there's some other like superfood, but that's always the one on the shelf that's like, hey, drink beets. They're helpful for nitric oxide.
Again, that comes back to some creative marketing by companies with very little science. I've tested probably, if not every beet product on the market, the majority of them, and 95% of the beet products out there don't contain any nitric oxide activity. So, and you think about this, because you have to conceptualize this from start to finish. So number one, the soil that the beets are grown in have to have sufficient nitrogen for them to accumulate nitrate. And then when you take the raw beets and make a beet powder out of it, that goes through a really stringent desiccation process, a lot of heat, and it destroys the nutrient density of that vegetable. So most of these beet products on the market are just dead beets. The only thing they do is turn your pee and your poop pink and red and cause a lot of anxiety, but they do nothing in regards to nitric oxide.
Well, I was thinking, I'm curious, my brain is thinking, how do you measure for nitric oxide activity if it takes all these other reactions to make nitric oxide? You'd need a body, right? Wouldn't you need a body?
That's right. Well, we measure these products, and in terms of supplements or products, we can quantify the amount of nitrate or nitrite in a given product or in a serving size and see if that's sufficient for the body to convert into any meaningful physiological active nitric oxide gas. And that's kind of our metric in terms of measuring these products. As I mentioned, 95% of the nitric oxide products out there, whether they're beets or other supplements, don't do anything. So you're just creating a lot of, I shouldn't say that. They have a lot of good ingredients in them that could provide some benefit, but they do nothing in regards to increasing or enhancing nitric oxide production.
Like if you did a salivary nitric oxide strip, for example, before and after someone consumed a bunch, no change.
That's right.
All right, cool. I was thinking about nitric oxide a lot when I was climbing high mountain ranges in the Andes recently. And do you think nitric oxide, is my thought process correct? Should I have been trying to boost my nitric oxide or improve my nitric oxide production to improve my resilience in higher altitudes?
Absolutely, without a doubt. We published on this, I think in 2007, and we were interested in the adaptive effects of people that live in Tibet. Because if you live in Tibet, that's 12,000 feet above sea level. So if you and I were to go to Tibet, fly to Tibet, it'd take us 3 to 4 days to acclimate. And we acclimate by producing more nitric oxide. So in our 2007 paper, we discovered that the natives of Tibet are able to live at high altitude, which, by the way, that's the partial pressure of oxygen is much less. So you're breathing in less oxygen per breath. So they've adapted to that lower oxygen tension by improving and upregulating their nitric oxide output. So even though they're breathing in less oxygen, they're delivering more oxygen per unit time because they're making about 50 to 100 times more nitric oxide than we do at sea level. And in fact, that's the whole basis for people training at altitude. So we send people, and we've done this in studies, take people in Houston, send them up to Denver or Mexico City, which is 5,000 feet above sea level. And if they spend 3 to 4 days there, then you see about a 40 to 50%, sometimes 100% increase in their nitric oxide production. And then when they come back down to sea level, they're like a well-oiled machine. So this is the adaptive effects of healthy people. Now you take a 50-year-old diabetic, overweight, hypertensive person to altitude, they're not going to do well at all because they can't adapt because their body cannot make nitric oxide. These are the people that get acute mountain sickness, high altitude pulmonary edema, and these are the people that can die from going to altitude. So our whole strategy and our philosophy is that if your body can't make nitric oxide because you can't adapt to a low oxygen environment, then you've got to take our nitric oxide and then we adapt for you to allow your body to better deal with these lower oxygen tension.
Yeah, I wish that nitric oxide stuff I wish this was more commonplace discussed when you're talking about like altitude sickness and adjusting, but it makes sense that it's not because it's not incredibly measurable, right? And we have it's debated how people would increase it, right? Because if there's all these products on the market and not that many work that beautifully, then I can see why it's not a common recommendation. I can understand where that maybe would be an issue.
I think, Krista, that's why what you do is so important in getting this information out to listeners. So it's one thing, we have to properly educate and inform not just consumers, but physicians and healthcare practitioners. But the challenge with that is that there's companies out there, and some of these companies I've been very close to that, are doing deceptive marketing and almost fraudulent marketing because they're positioning a product as a nitric oxide product when it does not generate nitric oxide. So we have to hold these companies accountable because they're confusing consumers, and especially if people are going to altitude or taking these products for the management of blood pressure, and they take this in good faith that it's going to generate nitric oxide as the label says it is, and then it doesn't. It's just not only is it disingenuous, but it's potentially very dangerous.
Is nitric oxide ever given in a hospital setting to improve someone for blood pressure issues or anything like that, right? Because it's normally delivered as a gas. So that would be the main place where...
No, that's right. The first FDA-approved indication for nitric oxide therapy was inhalative nitric oxide for premature babies born with pulmonary hypertension. So when babies are born premature, one of the last organs to fully develop is the lungs. And so premature babies have underdeveloped lungs. They don't get good oxygen exchange until they develop pulmonary hypertension. So now, 20, 30 years later, this therapy has saved hundreds of, probably millions of babies' lives. And now they're using it off-label for adults undergoing cardiopulmonary bypass surgery. There were a number of published clinical trials during COVID really sick, hypoxic COVID patients in the ICU were given inhaled nitric oxide and they got better. You improve blood oxygen saturation, you dilate the pulmonary circulation, and overcome what's called hypoxic pulmonary vasoconstriction.
Yeah. I wonder, why wasn't that more of a duh, right? Like, why wasn't that an automatic? Hey, we have this natural thing our body makes and it's antimicrobial and it dilates this and is really useful in this indication. Why is that not the automatic? So don't ask me.
Because it worked and because it wasn't a vaccine.
Mm-hmm.
That's the
not enough money. Not enough money tied to this. Not enough money.
That's right.
Follow that. So you just mentioned the profile of an overweight, hypertensive, pulmonary edema person. Let's talk about what happens when you give exogenous nitric oxide to that person, and also this COVID trial, right? Because the people that this is going to help, I mean, I want to talk about, we were just mentioning during, but really it's the post-COVID people that you're after, hindsight 2020, where they're not really feeling good. So what happens when you give exogenous nitric oxide to this profile that really needs it? And then also in long haul COVID?
Well, everybody's different. And so when we look at responses, kind of a general response, everybody's different. So when I take this lozenge, I don't notice any different. I don't feel any different. But if you take somebody who's a really sick person with a history of transient ischemic attacks, it's hypertensive, when they put that lozenge in their mouth, within seconds, they'll tell you that they feel a difference. In fact, if we use an ultrasound and just measure the carotid artery, within about 30 seconds of that lozenge, we can actually watch the carotid artery dilate. So that's just one vascular bed, but it's happening throughout the body. So not only is it a vasodilator that dilates the blood vessels and improves oxygen delivery and blood oxygen saturation, but it prevents vascular inflammation. And that was kind of our segue into COVID, because we recognized in March of 2020 that the people that were getting COVID and dying from COVID were the people who couldn't make nitric oxide. Those were the elderly, primarily African Americans with high blood pressure, diabetes, obesity, a previous heart attack. Those are the people who can't make nitric oxide. So when they got exposed to COVID, what nitric oxide typically does is, for instance, I use me as an example because I'm probably the best example out there. When we're exposed to COVID or the flu or any respiratory virus, our body recognizes that, and then we mobilize our immune system, and we do that through opening up blood vessels through nitric oxide. We go to the site of attachment. In respiratory viruses like COVID, it's usually the airway epithelium. And then our immune system generates a lot of nitric oxide over a short period of time, and that nitric oxide prevents the virus from replicating. But if you can't make nitric oxide, then that virus replicates, propagates throughout the body. You get the spike protein that causes vascular inflammation. Platelets start sticking together and clotting, and monocytes and neutrophils stick to the lining of the blood vessel. And you get, kidney disease and liver disease and pulmonary disease because there's not enough blood flow getting through those vessels now. And then you get small microclots that are causing strokes and heart attacks, and that all points to a lack of nitric oxide production. So that was our argument when we filed our investigative new drug application to the FDA was, okay, if these people are deficient nitric oxide, which basically explains every single etiology of COVID infection, from those susceptible to infection to binding to the ACE receptor, to the systemic inflammation and systemic disease that lasted long after the active infection, all could be remediated by giving nitric oxide. And that's exactly what we've seen in our drug trial. We've now dosed over 650 patients with our nitric oxide drug. It's a double-blind, placebo-controlled study. But even after 100 patients, we already saw a statistically significant difference between the two groups, the active and the placebo. So the science, our primary endpoints were hospitalization, admission to the ICU, and death. But we also measured their symptomology. So clearly, in one group, and of course it's double-blinded, we're blinded to this. The people in one group, if they got sick, their onset of symptoms, the symptomology, meaning that the time of the symptoms was completely abrogated in one group. And so at that point, COVID was a very predictable timeline. If you got exposed to COVID, 3 days later, you developed symptoms, and those symptoms, if you got really sick, would last for 7-10 days. You'd go to the ICU, they'd put you on a mechanical vent. 3 days later, you typically die. But in one group, we found that if they got symptoms, they were very mild symptoms. And then the other group obviously had the normal course of disease.
So let's talk about what you do, you stabilize nitric oxide and you've got these many patents. I mean, again, correct me. The bio is long. I think you have many patents on different things, and you have essentially a drug that you're trying to produce. I actually interviewed a researcher recently, and he was producing essentially the raw material for other people to put into products. I think the question is really, when I talked to him, I had to look for a particular ingredient in a product for it to be that particular raw material. In your case, that's not really an option because it has to be delivered in a very specific way. So you really have to have control of everything from start to finish, probably.
That's right. No, we produce and deliver finished products. So, and we've got only a handful of manufacturers who can do this. But obviously, we have to source the raw ingredients, and we have to make sure that we put this in together a form that keeps these active materials separated until this matrix falls apart in the mouth in the form of a lozenge. Then we generate the gas. So everything we do and every product that me or my companies bring to market generates nitric oxide gas. We can quantify it, we can verify it, and if it doesn't, we don't bring it to market. So you never have to guess if a Nathan Bryan product generates nitric oxide. If it has my name on it, you can guarantee that it does, and we've got the methods to verify it and quantify it. Obviously, we're going through FDA clinical trials, so these drugs aren't approved yet and aren't on the market. So the drug company's called Nitric Oxide Innovations. We've got 4 or 5 drugs going into clinical trials now for COVID-19, ischemic heart disease, got an Alzheimer's drug. We've got a topical technology for diabetic ulcers and decubitus ulcers, pressure wounds. That's really remarkable. It'll change the whole landscape of wound care. But as those drugs are going through the clinical trials, we've brought to market some over-the-counter dietary supplements and even, our own skincare line. So our nutritional and dietary supplement products are through a company called Bryan Nutraceuticals, and that can be found at no2u.com. That's no, the number 2, the letter u.com. And then we developed a skincare because once we knew how to make nitric oxide, then the question was, what else can we do with this? And the skin is an organ just like the heart or the sex organs. And without sufficient blood supply, then that organ fails. And so fine lines and wrinkles appear. You get dermatitis, you lose collagen, you lose hydration, and you look old. So in this dual chamber nitric oxide serum I developed, you apply this to the skin, 1 pump from each chamber, and it generates nitric oxide gas right there on the surface of the skin. And in fact, you can actually watch this product working before your eyes, because when you apply it to your skin will turn a light pink. And that's due to the opening up of the capillaries and increasing blood flow to wherever you apply it. And this is a completely new category in skincare. This is an unbelievable product. Most skincare and beauty products hide the blemishes, hide the fine lines and wrinkles. We get to the root of the problem and improve collagen deposition. We've got 4 published clinical trials on this technology. But an incredible product. It's called N101 nitric oxide serum through a company called Numa Nitric Oxide.
Are we going to get your before and afters of your skin, Dr. Bryan?
That's right. Yeah, I think it's proof principle that it works. But, it's one thing to work in individuals, but when you do a randomized controlled clinical trial and look at a number of different patients before and afters, it's really transformative. So I'm really proud of that product technology. And again, that's found at n101.com.
So I have to ask this question, and I could make up a bunch of answers, but I'd like to hear your answer. I mean, nitric oxide is made in the body, right? You've stabilized it exogenously. It fits under the dietary supplement category technically, right? So you could just proceed and do supplements so people buy this over the counter, but you're going drug route. Why are you going drug route? Is that to get into different types of audiences essentially?
Well, I'm trained as a drug discovery biochemist. And so, we get into academia and basic science research to give physicians new tools to treat, prevent, cure, or diagnose disease. That's really the basis of everything we did when I was in academia as a professor of medicine. So it was never my intent to develop a dietary supplement or nutritional product. But the beauty of that kind of program and route is now it's readily accessible to people all over the world, right? You don't have to have a prescription to get this.
Right.
But as you know, it's the wild, wild west because any other company can say the exact same thing that I'm saying without any evidence. And that's just basically the DSHEA Act, which basically allows dietary supplements to support basic structure, function applications in the human body. Mm-hmm. So my objective now, and it hasn't changed since 25 years in academia, is to deliver safe and effective nitric oxide product technologies into every major market segment around the world. I think we've been very successful with that in the nutrition dietary supplement space. We've had it in the skincare and beauty for the past 2 or 3 years. But in order for this to be mainstream and for everybody to know about it, just like taking niacin or niacin for lowering triglycerides or prescribing a pill for hypertension, if we go through the rigor of doing FDA-approved clinical trials, today, if you go to your primary care physician asking about nitric oxide, most doctors out there are going to look at you funny and don't know what you're talking about.
Right.
However, if we get a nitric oxide drug approved, then these physicians will learn about nitric oxide. They'll know how important it is. And now they can prescribe you not only an effective drug for that indication, but a drug without side effects.
Yeah.
And to me, that's the most important thing about what we're doing, because my research program was designed around this concept of restorative physiology. Most drugs are pharmacology, right? They're inhibiting certain biochemical reactions. And when you do that, there's always consequences, and they call those side effects. Mm-hmm. And I don't watch a whole lot of TV, but when I do watch TV and I see these drug commercials come on, they're 30-second drug commercials, 25 seconds of that 30-second commercial are side effects. Mm-hmm. I mean, and I don't know why people would even want to take, if they listen carefully to the commercials, no one in their right mind would take these drugs or even ask their doctor about these. Mm-hmm. So what we do is basically give what's missing. We give nitric oxide to the body at doses that the body normally produces. It's just so we're not inhibiting any reactions, we're not causing side effects. So this is a completely new paradigm in drug discovery. Yeah. And I think that's why it will change the face of healthcare, and it will be the way we treat people for the next 100 years.
How many years until we see nitric oxide entering the drug space? I mean, you're the guy with the first row seat.
Yeah, I think within the next 12 to 24 months, we'll start getting some of our drugs approved. Because here's the deal. It's so remarkable in its potency. We've been very fortunate and very diligent in trying to figure out, number one, is it safe, do no harm? But number two, provide a dose of nitric oxide that's not only safe, but it's efficacious in many different indications. Mm-hmm. So this takes, typically about 10 years and $800 million to get a drug to market. I think we've been able to fast track this, not only because of COVID, but because of our drug is so safe that now we're able to go straight into phase 3 clinical trials for any oral formulation we go to. Mm-hmm. So many of these, I think we've gotten feedback from the FDA. We know what to do. We have a clear regulatory path. We just have to do the study and let the drug perform. Mm-hmm. So I think within the next 18 to 24 months, we'll have our nitric oxide drugs approved on the market and continue to change lives all around the world.
Cool. Well, I wish you a lot of success. So the last question that people want to make sure we get in always is, we produce nitric oxide in our body, and we've covered this a little bit, but it's such a good place to kind of end before we get to where people should go find you online, which is, what is something that you think, like if you were trying to just improve your nitric oxide production on your own today for free, what would you go do?
Well, that's a very good question and a very common question. I tell people you have to do two things. Stop doing the things that disrupt it and start doing the things that promote it. Mm-hmm. So we can kind of delve into those. So people have to stop using mouthwash. It's clear evidence now that if you use mouthwash, you disrupt the oral microbiome, decrease nitric oxide production, your blood pressure goes up. And you have to get rid of fluoride in your toothpaste, fluoride in your drinking water. Fluoride's an antiseptic, it's a neurotoxin, and it kills your thyroid function. Mm-hmm. So buy fluoride-free toothpaste, get a home filtration system that removes fluoride and chlorine from your drinking water. Stop using antacids. Your body cannot and will not heal without stomach acid production because it shuts down nitric oxide production. Mm-hmm. Then stop eating a lot of high carbohydrate meals because the sugar in these diets stick to the enzyme that makes nitric oxide and makes it dysfunctional. So if you just stop doing those three things, number one, you're going to save money. Number two, your body's actually going to thank you for it. Mm-hmm. And then, just moderate physical exercise, as little as 20 minutes of moderate physical exercise a day, 20 to 30 minutes of sunlight or infrared sauna. There are certain wavelengths of light that stimulate nitric oxide production. Then throw in some more green leafy vegetables. And when all else fails and the people don't want to do that or can't do that, then we have product technology that does it for you.
What's the wavelength for stimulating nitric oxide?
Well, it occurs at both ends of the spectrum. So ultraviolet light, we realized that will cleave nitric oxide down to thiols. So obviously there's a limit of penetration of UV light into the skin. And then the other end of the spectrum is the near and far infrared. That frequency of light will actually knock nitric oxide off of metals. So it'll re-liberate any nitric oxide. And we call these photolabile stores. But if you're nitric oxide deficient, obviously you have less of these photolabile stores, so the efficacy of light therapy is going to be much reduced. So we like to tell people, if you're going to go out in the sun or sit in an infrared sauna or do light therapy, titrate up your nitric oxide levels before, take our nitric oxide supplement, or go eat some spinach or kale or arugula, or I would say beets, but most beets don't contain any nitrate, and then do the light therapy. And it makes everything else work better.
Cool. Where should people find you online?
I send people to my educational website. It's drnathansbryan.com. I'm not selling you anything on there. I'm just providing education. There's a 6-minute video. I do a monthly blog. I'm on Instagram, Dr. Nathan S. Bryan, Twitter at Dr. Nitric. I think social media, I'm not a big social media fan, but, I think it's the way of the future, and certainly the way most people get their information. So we have a pretty good presence on social media.
You should be
that's where I send
Dr. Nitric Oxide on both platforms. That would be way cooler, just so you know.
Well, sometimes those handles are taken.
Yeah, true. Probably. All right. Well, cool. I wish you the best of success with your drug trial, so we can be recommending things without side effects that will help people. I hope that goes seamlessly and you're very successful. Thanks for coming on today.
Thank you very much, Krista.
Sharing and reviewing this podcast is the best way to help us succeed with our mission to help integrate the best of East and West and empower you to raise the bar on your health story. Just go to reviewthispodcast.com/less stressed life. That's reviewthispodcast.com/less stressed life. And you'll be taken directly to a page where you can insert your review and hit post.